Okay, good morning everybody. So last class we talked about polarization. So we talked about uh, three types of polarization. We had actually seen three types of polarization, and the three types of polarization that we had discussed were circular polarization, and then we saw elliptical polarization, then we saw a linear polarization or plane polarization. Okay, now keeping that in mind, let's work out the problem. So what is given here is determine the polarization of a plane wave. I hope you know it's a plane wave. Plane wave is something where the wave is traveling in one direction. It's not spreading out. Okay. So, or the source is at a very, very far off point. Determine the polarization of a plane wave with E z of t equal to 4 e to the power of 0.25 z cos of omega t minus 0.8 z ax cap. And then, of course, you have a similar sign component with the ay direction. That means this electric field is having both an x direction and a y direction component. So now you have to find out what is the polarization. So let's start working on it. So first thing that we need to do is let us look at what is going to be the electric field at z equal to 0. At z equal to 0, let us find out how the electric field will look. Okay, at z equal to 0, if you look at the electric field, you will, and let us call the equation as E of x at 0 comma t. So that is the first component. Okay, so that if you see will be 4 e to the power of z is 0, therefore e to the power of 0, or I need not even write that particular term. Okay, and then what do I have? Cos of omega t, and then of course it is along the ax cap direction. Similarly, if I write the y component of this electric field again at z equal to 0 and time t, you are going to get 3 sine, then you are going to get omega t, okay, and the direction is ay cap. Is the step clear to you? Revant?
Yes, ma'am.
Okay, so all I have done is I just put it at z equal to 0. What is the equation I have written? Okay, now what we will do is let us write what is cos of omega t. So cos of omega t according to this equation will become E x component at z equal to 0 and time t divided by 4. And similarly here I will write sine omega t will become equal to E y at z0 time t divided by 3. Okay. Next, what we'll do is let us square and add. Okay. When you square and add, what will you get? You get ex naught t square by 4 whole square plus you get ey, the y component at 0t divided by 3 whole square is going to be equal to 1. Okay. Does this equation remind you of something? Does this equation remind you of something? Isn't it an equation of an ellipse? Anyone?
X square by a plus y square will be equal to 1.
Right. Okay. So this is an equation of an ellipse. So what do you conclude? You can conclude that the polarization is elliptical. The polarization is elliptical. So this is where the book is leaving. Okay, the book is leaving you at this stage. But then I would like you to just go one step ahead and then look at whether it is a right polarization or a left polarization, whether it is a right polarization or a left polarization. Now you look at this equation, you see the x component. You see the x component, you're finding that the x component is a cosine equation and a cosine function, and you're seeing that the y is a sine function. Okay, and if you write the relationship between them, you can write that sine of any x can be written as cos of x minus pi by 2. Yes or no? Okay, or you can see that the x component is leading. X component is leading. Okay, and I will therefore conclude that this is a left elliptical. I'll conclude that it is left elliptical polarization. Okay, or I will write it as LEP. Okay, in case you are not convinced with this answer, what I want you to do is just plot and see. Just plot and see. This is your AX, this is going to be your AY. Okay, now plot and see in which direction the plot will rotate. You will find that it will rotate like this. Okay, therefore it is left elliptical polarization. I have done this and shown you last class. Okay, all you have to do is you just do it at t equal to 0, then do it at t equal to pi by 2. You just do this and see. Then you will find that the first point will come here, the second point will come here, it will rotate like this. Okay, so you say it is elliptical polarization. Instead of doing all that, you can also go with this logic. If the x component is leading, okay, x component is leading means the x component value is going to be bigger when y component is going to be 0. So then you can see that it is going to be left elliptical polarization. Is this problem clear? Any
Yes.
doubts? Sahiti?
No doubt.
No doubts. Okay. So next, let us do the next part. And please remember, polarization, we always talk with respect to the electric field, not with respect to the magnetic field. We never discuss with respect to the magnetic field. Okay. So now let us look at the next problem. So when we go to the next problem, you can straight away see that what is given here is the phasor representation. And next thing is it is given in terms of magnetic field. It's given in terms of magnetic field. Both of these we don't want. So now how do we do this problem? So now what we have to do is, let me just write the equation looking at my paper only. Okay, so Hs of z equal to h naught e to the power of minus j beta z along the ax cap direction, then minus 2h naught e to the power of minus j beta z along the ay cap direction. If you are sufficiently smart, by just looking at this itself, you can see that there is no phase difference between the x and the y component. And you know that when delta equal to 0, when there is no phase difference, it has to be linear polarization. But when you write in an examination, don't write it this way. You have to get it in terms of electric field. Write it in terms of electric field. Okay. So how do you write it in terms of electric field? To write it in terms of electric field, just do what we have done. Maxwell's equation, do you remember we had written? So let's just write Maxwell's equation. So Maxwell's equation, let us take. You certainly know that you have to write del cross H is going to be equal to, okay, here we are going to write it in terms of phasor. Therefore, del cross H is equal to omega j omega epsilon E S. Okay. So now let's just put it here. Let us find the LHS. LHS, when you find, you're going to get del cross H is going to be AX cap, AY cap, AZ cap. Then you have dou by dou X, dou by dou Y, dou by dou Z. And then let us look at our H. H is having, you can see from the equation that H is having X component and Y component. So let us just put H XS and HYS, and this is 0. Okay. So now you can see that both these are functions of H is a function of Z. That means it is differentiable with respect to Z. It's differentiable with respect to Z. Okay, so let's just mark it. So it's differentiable with respect to Z. Similarly here, this is also differentiable with respect to Z. Okay, now open the bracket and see what you will get. Just work it out and see. So you will get AX cap, and then here you're going to get minus dou H Y S by dou Z. Okay, and then the next is going to be the y component. Okay, so minus a y cap, that when you do is going to give you minus dou h x s by dou z, right? Or I'll write it as minus dou h ys by dou z in the ax cap direction plus dou h xs by dou z in the ay cap direction. So just differentiate. Take these components and differentiate with respect to z. The first component you're going to take is going to be this component, the ay component. So take it and differentiate. When you differentiate, what are you getting? You're getting minus, then 2h naught, then you also get minus j beta, then you get the original part of it is going to be e to the power of minus j beta z along the ax cap direction, plus let's do the next one. The next one is going to be h naught into minus j beta, and then you get e to the power of minus j beta z along the ay cap direction. Okay, or let us just simplify it and write it. When you simplify it, you will get, let me see what I'm getting. So this is going to be the left hand side. Let's leave it as it is. Now let us write the right hand side. So the right hand side is j omega epsilon into es. So that's going to be equal to this minus 2 becomes plus 2, then j beta h naught e to the power of minus j beta z ax cap. Then the next one is going to be minus j beta h naught e to the power of minus j beta z along the ay cap direction. Next, what we do is we just need to get only our ES. Okay, to get ES, what do? Get everything else to the other side of the equation. So 1 by j omega epsilon, and then the rest of it is 2j beta h naught e to the power of minus j beta z ax cap, then minus j beta h naught e to the power of minus j beta z a y cap. Okay. Now, once we have done that, we just need to simplify it. Okay, I think I need to add one more page. Okay, so here what I will now do is, let me just finish this problem. So finally what I have got, I will show you. I am getting my ES is going to be equal to 2 beta, nothing, I've just mathematically simplified it, by omega epsilon e to the power of minus j beta z along the ax cap direction, and then minus beta h naught by omega epsilon e to the power of minus j beta z along the ay cap direction. Okay, once you have got this, don't leave it here. You need to write the harmonic representation. To do the harmonic representation, you know that it is the real part of ES e to the power of j omega t. Okay, therefore, this will become 2 beta h naught by omega epsilon, and real part. So real part of epsilon e to the minus j is going to be cos. So cos of omega t minus beta z along ax cap direction. And then on this side, what will you get? Minus beta h naught by omega epsilon. And again, it is real part. So real means cosine of omega t minus beta z along ay cap direction. How many of you understood this step? I just skipped one step, that's all. This part, I hope you all remember. Harmonic representation is real part of phasor representation into e to the power of j omega t. So what happens is, no, you just club together this e to the power of minus j beta z and e to the power of j omega t. So what will you get? E to the power of j omega t minus beta z. Similarly here also, e to the power of j omega t minus beta z. Then what is the real part of that? Real part of it is cosine. Okay, now you look at what you have got. You've got your electric field. This is what we wanted. Now you look at it. Both are cosine functions. Both are cosine function. No phase difference. No phase difference. Or you see delta equal to 0. Delta equal to 0. And both are cosine functions. No phase difference. Okay. Therefore, you conclude that this is linearly polarized. Ben?
Yes, ma'am.
You understood these steps?
Yes, ma'am.
Okay, so it's linearly polarized. So let's go to the next problem. Next problem is simpler. Let's try this. Here what is given? Again, the phasor representation is given. E naught e to the power of minus j beta z in the ax cap minus j ay e to the power of minus j beta z determine the polarization. Okay. So here once more, what we will do is let us write the not the phasor representation. From phasor, let us go to the harmonic representation. So that's going to be the real part of E S as a function of the phasor representation into e to the power of j omega t. Okay. So now let's just open it. Therefore, this is going to be the real part of E naught e to the power of j into omega t minus beta z along the ax cap direction. Then the next one will be minus j, because this j is there. Let's keep minus j, and then of course again e naught e to the power of j omega t minus beta z along the ay cap direction. Is this step clear? I just club together this j omega t and this j beta z. Okay, so I'm getting omega t minus beta z. Similarly here also omega t minus beta z. Oh, there is a small mistake in the, one sec. There is a mistake actually. I need to actually correct the in writing the question I have made a mistake. Let me just do that. Oh, I put a double e to the power of minus j beta z. I'm sorry, I should not do that. That is not there in the question at all. Oh, only this is there. I'm sorry. So in writing a question, typing, I have made a mistake. Okay. So now I hope this step is clear. Any doubts? Okay, now what we'll do is, what is the real part of exponential j theta? So it is cosine. So this is going to be, the first term is going to be E naught into cosine of omega t minus beta z along the ax cap direction. But what will this be? There is already a j. There is already a j. So what will you get? Cos theta plus j sine theta. Already there is a j. So j and j will become 1. Therefore here you will get plus E naught sine omega t minus beta z along the ay cap direction. Is this step clear? Nothing, yeah. I'll just show the rough work here. So it is j into cos theta. Okay, there is a minus also. Minus j into cos theta plus j sine theta. Okay, and you want the real part of it. So what will this be? So the real part of j cos theta then plus sine theta, right? So which will be real? So the real part of that means you are left with only sine theta. Did you get this step? Yeah. So that's the reason why you're getting this. So now we look at this and tell me
Negative
what kind
sign.
of
Minus sine theta it is. J into j minus.
but already there is a minus here.
Oh,
Already there is a minus, so that minus will go here. Okay. Yeah. So now can you guess what is going to be the polarization? Is there a phase difference between X and Y? No phase difference. No phase difference between X and Y component. Okay. So what do you conclude?
cos and sine 90 degrees phase.
Oh, sorry. Sorry. What am I telling? Yeah, cos and sine 90 degrees. Okay. So now what will you write? Write phase difference. Phase difference is delta equal to, is it plus pi by 2 or minus pi by 2? I wrote it in the previous thing. I've written sine theta is equal to cos x minus pi by 2. Okay, use that here. Or if you still have any problem, just try to plot it. Plot it and see. Ax, ay. Okay, and then plot it and see what is going to happen at a time t equal to 0 and z equal to 0. Just plot it and see. And another thing that you are observing here, I'm sorry, not this one, I have gone to the wrong problem. Okay, so you can plot it yourself and see. Okay, so there is a phase difference of pi by 2. Okay, and it is plus or minus that you decide and tell me. Which is leading, X is leading or Y is leading?
X is only leading.
Yeah, if X is leading, then it is? X is leading. If X is leading, it is left. Just draw it here and see, no, Ax, Ay at Z equal to 0. You do it and see. And at a time t equal to 0, what will you get? At a time t equal to 0 and Z equal to 0, what will this equation become? Cosine of 0 is 1. So you get Y component will become, X component will become E0, Y component will become 0. Then the next will be at pi by 2. You tell me what will happen. At pi by 2, this first part will become 0. The second part will become plus E0. Therefore, it will be traveling like this. Are you getting this logic, guys?
Yes, ma'am.
Yeah. And what polarization is this going to be?
Left polarized.
Left polarization. Is it circular, elliptical? What is it?
Circular.
Circular, because both are the same. The magnitudes are the same. Therefore, you conclude that it is left circular polarization. I know I have exceeded my brief a little for this part of the syllabus. That is because just teaching what was in that book is not going to be useful for antennas paper. Okay, antennas or microwaves. But if I do it this way, no, this will be complete. You can tell your teachers not to teach anything also. Still, you will be all right. Is it fine, guys? So this is what I wanted to do today. So it's done. I know we have started lagging a bit with the syllabus. The fault is not mine. It is because of the low attendance. I'm a human being. So what happens is, no, it works on my head. If I see some 30 and odd people there, then I feel comfortable to teach. Otherwise, I don't feel very comfortable teaching. Otherwise, I was supposed to go ahead more with the syllabus. Okay, any doubts that you want to ask about Saturday's test? Saturday's test, it's going to be 8 questions. Okay, all this is not, polarization is not there for the test. What we have done till last class is only there for the test. Then what else? 8 questions. The marks can range from 2, 3, even 1 maybe. Okay, totally 20. So please enter on time. Please keep your camera open. Log into your LMS. Your question paper will appear as a PDF single page. So look at that, and on white paper, prepare the white paper as the academic chairperson has instructed. Additionally, across the diagonally, put in red on every page that you're writing, put your number in red color, enrollment number. Then start writing on that. Okay. As soon as you finish your examination, please write all the steps so that it becomes easier for me to grade you. I will be liberal, but then if there is nothing on the paper, I cannot give you marks. The next thing is, please upload it on LMS like how you will upload your assignments. Upload it like how you will upload. Madam, I don't have laptop. Please borrow somebody's laptop for a day, please. I'm sure you can do that. Please borrow. In the third year of engineering, if you say you don't have a laptop, who can help you? And the proctoring, you have seen that the mail from Professor Kishore, right? It very clearly says faculty have to do proctoring. So kindly arrange for laptops. I'm sure a neighbor or some friend, somebody, you just borrow the laptop for a day. And that laptop you use for your this one proctoring. Okay, and then you can just take out the questions as soon as you see from LMS, and then you write your examination keeping the camera open. And after the examination is over, there is a time given, 5 minutes is a time given to you for uploading it. Please upload it immediately. After that, it will not accept. And please keep your camera open so that your face and the desk is seen. Sitting in third year, you cannot say you don't have a laptop. If you don't have a laptop, kindly borrow for a day. Okay, because all tests hereafter will be like this only. What if there is a power cut during the exam? Will you allow us while we are trying to rejoin again? Yeah, that's why I'm telling you. First thing is, if possible, just to take a picture of you. I'm sure you have 100 phones at home. Okay, take the picture of your question paper immediately from PDF. That PDF, you just take it immediately on your phone. So that even if power goes, no, you can keep writing your examination. But then, if power goes, that's not very difficult for us to find out. If too many people keep losing their power. Okay, and it's only 65 papers. People who are capable of writing on their own, if they will write it. And other people, if they're copying, you can keep your book open. I have no problem. But if you keep your book open, you will lose marks. You will lose time. Okay, so why are we talking of if there is a power cut? Let us see. Let's see how things are going.
Ma'am, this writing enrollment number across the paper, can we make it digital? Like take a print of watermark?
No, printed watermark you can do all kinds of things with it. I don't want printed watermark.
That seems very distracting, ma'am, if we do it before. Once we write, I think we will have to write
write your paper and then do it.
In case we forget.
In case you forget, you get 0 marks. You write it, yeah. What distraction? It is just one thing you're diagonally writing. You please write it.
It's in red and very bright color, ma'am.
It's okay, write it in red. It will distract me more than it distracts you.
Okay.
Okay, so let's do it. And see, please don't copy because I have given the job of invigilation. I'll be one and there will be 2 more invigilators. And you are divided into small groups. So you will be seen. And if you're not switching on your camera also, you will be seen. And that just means that you're getting a 0 mark. So I am going with whatever instruction has been given. And the instruction is very clear that we have to do proctoring. Nothing very big will come. It will not even be full problems. I think one full problem is there. Otherwise, all are bits of problems only. Small portions. But don't waste time. Because if you start searching for equations and all that in the exam hall, I mean, when you're writing the exam, that will be bad. What I suggest is, in your own interest, as soon as the question paper appears, please take a PDF. Take a picture of that. Then keep on writing your answer and finally upload it. Is that clear, guys?
Yes, ma'am.
Yeah. But don't worry, see, camera is there. So people who claim they don't have laptops, they should borrow a laptop for a day. I'm sure your neighbors and so many people will have a laptop. Or go and sit in some friend's house and do it. Just 1 hour only, na? And this power cut business would have been there even if it was MCQ. So there's nothing great about that. Okay. Fine then, I will stop the recording, stop the class also.